Hello guys, who is watching this video. I will discuss the mathematics in our world. This is the topic that I will present. So, let's start. Patterns and numbers in nature and the world. Patterns defined as regular, repeated, occurring forms or designs, identify relationships, find logical connections to form generalization and predictions. Patterns in nature are visible regularities of form found in the natural world and can also be seen in the universe. Nature patterns are not just to be admired, they are vital clues to the rules that govern natural processes. Let us learn the type of patterns. The first pattern is symmetry, a sense of harmonious and beautiful proportion of balance or an object is invariant to any various transformation. Symmetry can be categorized into two, the reflective and rotational symmetry. Reflective symmetry, a symmetry in which the left and the right sides of the organism can be divided into approximately mirror images of each other along the midline. Symmetry indicates that you can draw an imaginary line across an object and the resulting parts are mirror image of each other. It is also called as bilateral symmetry. The example of this is an animal mainly have reflective symmetry and also a human face. This butterfly and eagle is also an reflective symmetry. Rotational symmetry. It means that the object or image can be turned around a center point and match itself some number of times. The smallest measure of angle that a figure can rotate while still preserving the original position is called angle of rotation. To compute the angle of rotation, we have the formula 360 degree divided by n, where n is the order of symmetry. It is included in this type are three-fold symmetry, four-fold symmetry, five symmetry, and others. These gumamela have a five-fold symmetry, and this spiderwort flower have three-fold symmetry. Fractals. A curve or geometric figure, each part of which has the same statistical character as the whole. A fractal is a never-ending pattern found in nature. The same shape is replicated in a process called self-similarity. The pattern repeats itself over and over again at different scale. For example, if a tree grows by repeating branches, the same kind of branching can be seen in lightning bolts and the veins in our body. Spiral pattern. A spiral is a curved pattern that focuses on a center point and, and a series of circular shapes that revolve around it. The reason for why plants use a spiral form, like the leaf picture above, because they are constantly trying to grow but stay secure. A spiral shape causes plants to condense themselves and not take up as much space, causing it to be stronger and more durable against the elements. The example of spiral pattern is a shell, a heart, even a galaxy form a spiral pattern. Meanders, a winding curve or bend of a river or road. Meanders are sinus bends in rivers or other channels which form as a fluid. Most often water flows around bends. The example of this is the Agusan River. It's the longest river in the Philippines, and any river in the north. Waves. Waves are disturbances that carry energy as they move. Mechanical waves propagate through a medium air or water, making it isolates as they pass by. The wave pattern is most often seen when looking at the ocean from above. However, you can also see wave patterns in grass as the wind blows through it. Even sand make a waves pattern through the action of waves. Wind. Tessellations. Tessellations in nature are often not very regular in structure, and no real-world tessellation strictly meets the mathematical definition of tessellations. Distinct shapes are formed from several geometric units, tiles that all fit together with no gaps or overlaps to form an interesting and united pattern. The example of this is the arrays of hexagonal cells in a honeycomb, or the diamond-shaped scale that pattern snake are natural example of tessellation patterns. Patterns are also seen in the external appearance of the animals. Tigers have a distinctive reddish-orange fur and dark stripes like some of the cats. So, that is our lesson, and let's go to the next topic, the Fibonacci sequence. Fibonacci sequence is a set of numbers that start with 1 or a 0, followed by a 1 and proceeds based on the rule that each number, called a Fibonacci number, is equal to the sum of the preceding two numbers. If the Fibonacci sequence is denoted Fn, where n is the first term in the sequence, the following equation obtains for n equals to 0, where the first two terms are defined as 0 and 1 by convention. So this is the example. In some texts, it is customary to use n equals to 1. In that case, the first two terms are defined as 1 and 1 by default, and this is the result. The Fibonacci sequence is named for Leonardo Pisano, also known as Leonardo Pisano or Fibonacci, an Italian mathematician who lived from 1170 to 1250. So, let's find the background of Fibonacci sequence. The origin problem that Fibonacci investigated in the year 1202 was about how fast rabbits could breed in ideal circumstances. Suppose a newly born pair of rabbits, one male, one female, are put in a field. Rabbits are able to mate at the age of 1 month, so that at the end of its second month, a female can produce another pair of rabbits. Suppose that a rabbit never dies and that the female always produces in one pair, new male and one female, every month from the second month. This is the result. The number of pairs of rabbits in the field at the start of each month is 1, 1, 2, 3, 5, and so on. The Fibonacci sequence is related to the golden ratio, a proportion roughly 1.618 that occurs frequently throughout the natural world and applied across many areas of human endeavor. Both the Fibonacci sequence and the golden ratio are used to guide designs for architecture, website, and user interfaces, among others. We can see a golden ratio in sunflower, shells, and even the picture of Mona Lisa. And there's so many more that we can see in the surrounding. We have seen in the preceding lessons how evident mathematics is in the natural world, especially how the patterns that we observe in nature follow a logical and mathematical structure. It is therefore important that we learn mathematical concepts and apply them in solving societal problems. And that is connected to our next topic, the mathematics for organization. A lot of events happen around us. Several children have already been born, liters of waters have been consumed, and thousands of comments pictured in FB have been posted. For us to make sense of all available information, we need mathematical tools to help us make sound, analyze, and better decisions. So, mathematics help us organize patterns and regularities in our world. The example of these are a particular store can gather data on the shopping habits of its customers and make necessary adjustments to help drive sales. Scientists can plot bird migration routes to help conserve endangered animal population. Social media analysis can crunch all online posting using software to gauge the netizens' sentiments on particular issues or personality. Mathematics for control. Mathematics help control nature and occurrence in the world for our own good through mathematical modeling. It is interesting then to ponder on how mathematics, an invention of human mind, seems to permeate the natural laws that hold the universe together. The example of these are the photographers could capture a single moment through a snapshot. Videographers could record events as they unfold. Painters and sculptors could create masterpieces in interpreting their surroundings. Poets could use beautiful words to describe an object, and musicians could capture and reproduce sounds that they hear. Mathematics for prediction. They work in the sense that predictions are based upon a careful analysis of patterns which are essentially recurring events. Patterns can found in languages, science, and even the arts. The key to being recognized patterns can provide the basis for us to later make predictions based on our observation of the repetition of pattern and then making a subsequent prediction based on the data. Mathematics helps predict the behavior of nature and phenomena in the world. The example of these are the weather is a prime example. Based on historical patterns, meteorologists can make forecasts to help us prepare for our day-to-day activities. They can also warn us of weather disturbances that can affect our activities for weeks or months. Astronomers also use to predict the occurrence of meteor showers or eclipses. Mathematics for indispensable. Mathematics help us understand the world and provides an effective way of building mental discipline. Math encourages logical reasoning, critical thinking, creative thinking, abstract or spatial thinking, problem solving ability, and even effective communication skill. Mathematics has numerous applications in the world, making it indispensable. If you are becoming a doctor, an engineer, an accountant, a public servant, or a chef, a knowledge of mathematics will be helpful. At the most basic level, logical reasoning and critical thinking are crucial skills that are needed in any endeavor. As such, the study of mathematics should be embraced as it paves the way for more educated decisions and in a way bring us closer to understanding the natural world. And that is all the topic I discussed. And thank you.
Problem solving and reasoning. Inductive and deductive reasoning. Inductive reasoning is the process of drawing a general conclusion by observing a pattern based on specific instances. Example below is the reasoning of inductive. 3 plus 3 is equals to 6. 6 plus 3 is equals to 9. 9 plus 3 is equals to 12. Pattern observe. Add 3 to the previous term. Conjecture. The next number is 15. The deductive reasoning is the process of using premises, accepted facts, and logical principles to arrive at a specific conclusion. Examples below are what geometry 2.3. If B is Q, if B Q, if Q is R, if B is R. Something like that. Deductive reasoning, acceptance of premises. Monkey likes bananas. Lucy is a monkey. So it implies that monkey's name is Lucy and Lucy is the monkey. So the conclusion is Lucy likes bananas because Lucy is a monkey. Intuition, proof, and certainty. Intuition refers to a quick or immediate or ready insight without evident rational thought. In a mathematical sense, it is associated with common sense thinking without the need for conscious reasoning. Example: what would be the product of 378 plus 113 over 2? The answer would be around 200 plus. That would not be the exact number, but it is somehow accurate and mostly right, having solved it within seconds. Proof is a process of establishing validity of a statement by derivation from other statements in accordance with the principles of reasoning. In a mathematical sense, it defines a statement to be true in a quantitative measure used on logical reasoning. It shows a statement to be true using definitions, theorems, and postulates. The types of proofs. Number one, direct proof. Its meaning, showing how it came to be. Example: two consecutive integers up to 37. Find the integers in x plus 1 is equals to 37. The answer would be 18 and 19. The other one is indirect proof, known as proof by contradiction. It begins by assuming the opposite of the statement that is to be proven. Example: 1 plus 1 will always be equal to 2, but will not be 3, unless we add another value to make it 3. Then we can call it a direct proof. Certainty is the quality of being certain or known, especially on the basis of evidence. In a mathematical sense, the quality of being reliably true. Mathematical knowledge consists of those mathematical propositions that are objectively warranted as true or logically valid, hence can be claimed to be known. Example: probability is a numerical description of how likely it is that a proposition is true. Probability can be imagined in numerical bases such as 0 and 1. 0 indicates impossibility, while 1 indicates certainty. The higher the probability of an event, the more likely it is that the event will occur. Polya's 4 steps in problem solving. Step 1. Understand the problem. Sometimes the problem lies in understanding the problem. If you are unclear as to what needs to be solved, then you are probably going to get to wrong results. In order to show an understanding of the problem, you, of course, need to read the problem carefully. Sounds simple enough, but some people jump on the gun and try to start solving the problem before they have read the whole problem. Once the problem is read, you need to list all the components and data that are involved. This is where you will be assigning your variable. Devise a plan. When you devise a plan, you come up with a way to solve the problem. Setting up an equation, drawing a diagram, making a chart are all ways that you can go about solving the problem. In this tutorial, we will be setting up equations for each problem. You will translate them just like we did in tutorial 2. Algebraic expression and tutorial 5 properties of real numbers. Let's just ignore this tutorial 2 algebraic expression, tutorial 5 properties of real numbers. Ignore that. Step 3. Carry out the problem. The next step, carry out the problem. Carry out the plan, is big. This is where you solve the equation you came up with in your devise a plan step. The equations in this tutorial will all be linear equations. If you need help solving them, by all means, also ignore the end part of the step 3. Look back. You may be familiar with the expressions "don't look back." In problem solving, it is good to look back, check and interpret. Basically, check to see if you used all your information and that the answer makes sense. If your answer does check out, make sure that you write your final answer with the correct labeling.
In this topic, we will discuss about elementary logic. Logical operators or connectives. The area of logic that deals with propositions is called The propositional calculus or propositional logic. We use letters to denote propositional variables like P, Q, R, S, etc. Example of this is let P be the proposition Spider-Man is a Marvel Comics superhero, and Q be the proposition Stan Lee is the creator of the Spider-Man character. Compound propositions are formed from existing propositions using logical operators. Logical operators are words or symbols that join two sentences to produce a new one. And here are the most commonly used logical connectives or operators. The negation, conjunction, disjunction, exclusive or conditional, and biconditional. Negation. This symbol can read as not P. It is not the case that P. It is false that P. It is not true that P. Some teachers and students prefer using this curvy line to represent negation. Example of this is let P be the proposition yellow is a color. So, not P is the proposition yellow is not a color. Conjunction. This symbol can we read as P and Q, P moreover Q, P although Q, P still Q, P furthermore Q, P also Q, P nevertheless Q, P however Q, P yet Q. Example. Let P be the proposition I like milk, and let Q be the proposition I like coffee. Number 1. P and Q. I like milk and I like coffee. Number 2. Not P and Q. I do not like milk but I like coffee. Number 3. P and not Q. I like milk but I don't like coffee. And number 4. Not P and not Q. I don't like milk nor coffee. Disjunction. The symbol of this is read as P or Q. P unless Q. Example is P be the proposition 2 is prime. Let Q be the proposition 2 is even. And number 1, P or Q. Example is 2 is a prime and 2 is even. Number 2, not P or Q. 2 is not a prime but 2 is even. Number 3, P or not Q. 2 is a prime but 2 is not even. Number 4, not P or not Q. 2 is not a prime nor even. Exclusive or. The symbol of this is read as P or Q, P, X or Q, P exclusive or Q. Example, let P be the proposition Ram is in Italy at the moment. So, it means Ram is in Italy or Japan at the moment. We choose exclusive OR instead of disjunction because Ram cannot be in Italy and Japan at the same time. Conditional. The symbol of this can read as if P then Q. P implies Q. If P, Q. P only if Q. P is sufficient for Q. Conditional synonyms. Some of the ways reverse the order or P and Q but have the same connotation. Q if P. Q whenever P. Q is necessary for P. Q follows from P. Q provided P. Q is a logical consequences of P. The example for conditional is let P be the proposition I buy a smartphone, and let Q be the proposition I get a free SIM card. Letter A. If I buy a smartphone, then I can get free SIM card. Letter B. If I buy a smartphone, then I don't get a free SIM card. Letter C. If I don't have a smartphone, then I get a free SIM card. And letter D. If I don't buy a smartphone, then I don't get a free SIM card. Biconditional. The symbol can read as P if and only if Q. P is equivalent to Q. P is a necessary and sufficient condition for Q. Example. Let P be the proposition Paul is a singer, and let Q be the proposition Paul knows how to sing. So it means Paul is a singer if and only if he knows how to sing. Quantifiers. Quantifiers describe the quantity of objects in the domain of a function or set. They describe the quantity of objects that meet some defined characteristics. Here are the universal quantifiers and the existential quantifiers. In universal quantifiers are for all, every, none, no. In existential quantifiers are some, there exists at least one. Example. Write universal quantifiers in math language. Letter A. For all real numbers x and y, if xy is greater than 0, then either x and y are positive or x and y are negative. Letter B. For all integers x and y, x plus y is an integer. Letter C. For all real numbers x and y, if x plus y equals to 0, then x equals to negative y. Letter D. Let x and y be real numbers not equal to 0. If x, y equals to 1, then y equals to x raised to negative 1. Variables. It is represented by a letter like x or y, a symbol for a value we don't know yet. The advantage of using variables is it allows you to give a temporary name to what you are seeking so that you can perform concrete computations with it to help discover its possible values. Example: 2x plus 3 equals to x squared. X minus 3 plus x equals to 177. 2 times y minus 1 equals to y plus 4. Formality. Is a formal statement of the meaning of a word or group of words, and it could stand alone. Example of this is a definition of right triangle. What is the exact or formal definition of this? A right triangle consists of two legs and a hypotenuse. The two legs meet at a 90-degree angle, and a hypotenuse is the longest side of a right triangle and is the side opposite the right angle. Theorem. A theorem is a statement that can be demonstrated to be true by accepted mathematical operators and arguments. In general, a theorem is an embodiment of some general principle that makes it part of a larger theory. The process of showing a theorem to be correct is called a proof. Example of a theorem that we all know is the Pythagorean theorem. This is a very well-known theorem in mathematics. The theorem stated that the square of the hypotenuse of a right triangle is equal to the sum of the squares of other two sides. If the hypotenuse, which is the side of the right angle or the long side, is called C, and the other two sides are A and B, then this theorem with the formula A is squared plus B squared plus C squared. You will notice that the theorem is precise in the form of if-then statement. The if-then statement is one of the statements in logic. So a statement could not be considered theorem unless it was proven true using mathematical logic. Proof. To be able to say that a theorem is true, it should be undergo on the process of proving. But what do we mean by proof or mathematical proof? Proof is a vigorous mathematical argument which unequivocally demonstrates the truth of a given proposition. Different methods of proof: deductive, inductive, direct proof, indirect proof, proof by counterexample, proof by contradiction. Proposition. When we say proposition, it is a declarative statement that is true or false, but not both. This statement is another major part of formality since all types of proposition are precise and concise. Different proposition: negation, conjunction, disjunction, conditional, and biconditional.
Good day everyone. In this video, I will discuss data management. First, let us define what is data management. It is a process by which information is acquired and processed to ensure the accessibility and reliability of the data for its users. One of the most important tools in processing and managing such information is statistics. Statistics. It is a science which deals with the collection, organization, presentation, analysis, and interpretation of data so as to give a more meaningful information. Statistics is subdivided into two branches, namely descriptive statistics and inferential statistics. Descriptive statistics refers to collection, organization, summary, and presentation of data, while inferential statistics deals with the interpretation and analysis of data where conclusion is drawn based from the subset of the population.
Level of measurement. Nominal measurement. Numbers or symbols are used to code or classify each element in the population. Note that the assigned numbers have no numerical meaning. Example: gender, educational background, and employment status. Ordinal measurement uses numerical category that expresses the meaningful order. There is no indication of distance between positions. Categories are ranked according to the order of their value on the property, like first, second, third, or oldest, next oldest, and youngest. Example: rank in beauty pageant and class ranking. Interval measurement has equal intervals. There is significance to the distance between any two values. It tells us that one unit differs by a certain amount of the property from another unit. It has no absolute zero. Example: aptitude test and temperature. Ratio measurement. A variable measured at this level not only includes the concepts of order and interval, but also includes the ideas of nothingness or absolute zero. Example: measurement of height, weight, and ages. Measures of central tendency. It is a measure of central tendency or center location. It is a single value that is used to identify the center of the data set or set of observations. Mean. The mean, also known as the arithmetic average, is the sum of all the observed values divided by the number of observations in the dataset. It can be computed as mean equals summation of x divided by n. For example, the score of 7 students who are selected randomly in a class are as follows: 32, 35, 38, 38, 45, 48, and 50. M equals summation of x divided by n. So we will add all the scores of the 7 students. So mean equals 286 divided by 7 equals 40.86. Median. The median is a single value which divides array observations into two equal parts such that 50% of the observations falls about it and the remaining 50% falls below. x tilde equals m sub 1 plus m sub 2 divided by 2, where m sub 1 and m sub 2 are the two middlemost values. For example, the score of 7 students who are selected randomly in a class are as follows: 32, 35, 38, 38, 42, 45, 48, and 50. So, x tilde equals m sub 1 plus m sub 2 divided by 2. X tilde equals 38 plus 42 divided by 2. Median equals 40. Mode. The mode is an observation that occurs most frequently in the given data set. For example, 1, 2, 3, 4, 5, 5, 5, 6, 7, 8. The mode is 5 since it has the highest frequency. Weighted mean. The weighted mean is a type of mean that is calculated by multiplying the weight associated with a particular event or outcome with its associated quantitative outcome and then summing all the products together. X equals summation of f sub I times x sub I divided by summation of f sub I. Let's try to solve this problem. X equals summation of f sub I times x sub I divided by summation of f sub I. X equals summation of 3 times 95 plus 1 times 89 plus 2 times 92 divided by summation of 3 plus 1 plus 2. X equals 558 divided by 6 equals 93. Measures of dispersion. Measure of dispersion or measure of variation is a quantity that measures the spread or variability of the values in a given set of data. Range. The range of a set of data is the difference between the largest and the smallest values. Difference here is specific. The range of a set of data is the result of subtracting the sample maximum and minimum. Range equals maximum minus minimum. For example, 108, 114, 122, 125, 141, 149, 151. Range equals 151 minus 108 equals 43. Variance. Variance is the expectation of the squared deviation of a random variable from its population mean or sample mean. Variance is a measure of dispersion, meaning it is a measure of how far a set of numbers is spread out from their average value. Variance equals summation of the product x minus mean squared divided by n minus 1. Standard deviation. It is the positive square root of the variance. Standard deviation equals the square root of summation of product x minus mean squared divided by n minus 1. Paano kaya natin makukuha ang variance and standard deviation nito? Variance. Variance equals 1752 divided by 7 minus 1. Variance equals 1752 divided by 6 equals 292. Standard deviation. Standard deviation equals the square root of 292 equals 17.08. Measures of relative position. It is a statistical measure the specific location of an observation relative to the other values when the data are in rank order. Percentile, denoted by P sub I, is a value that divides an array of observations into 100 equal parts in order that I% of all the observation lies below P sub I. Quartile, denoted by Q sub I, is a value that divides an array of observations into 4 equal parts in order that I times 25% of all observation lies below Q sub I. Decile, denoted by D sub I, is a value that divides an array of observations into 10 equal parts in order that I times 10% of all the observations lies below D sub I. Here is the formula to get the percentile, quartile, and decile. Example of it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In this problem, we are looking for the 30th percentile, 3rd quartile, and 8th decile. To get 30th percentile is P sub 30 equals n times I divided by 100 equals 10 times 30 divided by 100 equals 300 divided by 100 equals 3. 3 is the location of the 30th percentile. 3rd quartile. Q equals n plus 1 times I over 4 equals 10 plus 1 times 3/4 equals 11 times 3/4 equals 8.25 or 8. 8 is the location of the 3rd quartile, while the 8th decile is D sub 8 equals 8 times the sum of 10 plus 1 divided by 10 equals 88 divided by 10 equals 8.8 or 9. 9 is the location of the 8th decile. Box and whisker plot. It is a method for graphically depicting groups of numerical data through their quartiles. Box plots may also have lines extending from the boxes, indicating variability outside the upper and lower quartiles. Steps in the construction of box and whisker plot. Number 1. Arrange the values in an increasing pattern. Second, compute for the first, second, and third quartile. Third, locate the 5 numbers, the lowest and the highest values, first, second, and third quartile, in the number line, and draw a box above covering the first, second, third quartile, then draw a line segment across the box passing through the median. And last step is connect the box in the extreme values by a line segment. Probabilities and normal distribution. What is normal distribution? Normal distribution, also known as the Gaussian distribution, is a probability distribution that is symmetric about the mean, showing that data near the mean are more frequent in occurrence than data far from the mean. In graph form, normal distribution will appear as a bell curve. Properties. It is symmetric. A normal distribution comes with a perfectly symmetrical shape. This means that the distribution curve can be divided in the middle to produce two equal halves. The symmetric shape occurs when one half of the observations fall on each side of the curve. The mean, median, and mode are equal. The middle point of a normal distribution is the point with the maximum frequency, which means that it possesses the most observations of the variable. The midpoint is also the point where these three measures fall. The measures are usually equal in a perfectly distribution. Mean, median, and mode divides the curve into equal parts. The lower 50% of data and upper 50% of data. The curve is horizontally asymptotic. This means that the curve won't touch the x-axis. How to solve for probability? Given a normal distribution with mean equals 50 and standard deviation equals to 10, x assumes a value between 45 and 62. Z equals x minus mean divided by standard deviation equals 45 minus 50 divided by 10 equals negative 5 divided by 10 equals negative 0.5. Z equals x minus mean divided by standard deviation equals 62 minus 50 divided by 10 equals 12 divided by 10 equals 1.2. So, hahanapin natin yung negative 0.5 and 1.2 sa Z table. So, equivalent ng dalawa ay 0.19146 and 0.38493. Add natin yung dalawa to get the probability. So, 0.19146 plus 0.38493 equals 0.5764. So, that is the probability of linear regression and correlation. Linear regression is a linear approach for modeling the relationship between a scalar response and one or more explanatory variables. The case of one explanatory variable is called simple linear regression. For more than one, the process is called multiple linear regression. Linear regression models have become a proven way to scientifically and reliably predict the future because linear regression is a long-established statistical procedure. The properties of linear regression models are well understood and can be trained very quickly. Linear correlation, a measure of the degree of association between two variables that are assumed to have a linear relationship, that is, to be related in such a manner that their values from a straight line when plotted on a graph. Linear correlation provides an index of the degree of constant change in the value of one variable y for each unit change in the value of another variable x. Correlation is used to describe the linear relationship between two continuous variables. Example, height and weight. In general, correlation tends to be used when there is no identified response variable. It measures the strength, qualitatively, and direction of the linear relationship between two or more variables. Types of correlation. Number one, positive correlation. A direct relationship between two variables exists. That is, as one variable increases or decreases, the other also increases or decreases. Negative correlation. An inverse relationship exists between the variables. Here, one variable increases as the other decreases or vice versa. Zero correlation exists when scores in one variable tend to score neither systematically high nor systematically low in the other variable. It indicates that there is no correlation between the variables. Least squares regression line. If the data shows a linear relationship between two variables, the line that best fits this linear relationship is known as a least squares regression line, which minimizes the vertical distance from the data points to the regression line. The term least squares is used because it is the smallest sum of squares of errors, which is also called the variance. Least squares regression line is used to predict the behavior of dependent variables. The least square method provides the overall rationale for the placement of the line of best fit among the data points being studied. Here is an example and also the information needed to solve for it. So, after natin mailagay sa table, ang susunod natin gagawin ay ipa-plot sa Cartesian plane. Next step ay complete the table. The x, y, xy, and x squared. So, A equals 5 times 61 minus 15 times 18 divided by 5 times 60 minus 15 squared equals 305 minus 270 divided by 300 minus 225 equals 35 minus 75 equals 0.47. B equals 3.6 minus 0.47 times 3 equals 3.6 minus 1.4 equals 2.2. Y equals 0.47x plus 2.2. The trend of the line is slightly increasing with steepness or inclination of 0.47 per unit and y-intercept of 2.2. Linear correlation coefficient. The linear correlation coefficient is a number calculated from given data that measures the strength of the linear relationship between two variables, x and y. Here is the formula needed. R equals n times the summation of xy minus the summation of x times the summation of y divided by the square root of n times the summation of x squared minus the summation of x squared times the square root of n times the summation of y squared minus the summation of y squared. So here is the information needed in solving the linear correlation coefficient. Let's try to solve this. R equals 5 times 61 minus 15 times 18 divided by the square root of 5 times 60 minus 15 squared times the square root of 5 times 74 minus 18 squared equals 305 minus 270 divided by the square root of 300 minus 225 times the square root of 370 minus 324. R equals 35 divided by the square root of 75 times the square root of 46 equals 7 divided by 5 the square root of 3 times the square root of 46 equals 7 the square root, or rather 7 divided by the square root of 138 equals 60. So that's all